come to that. Y is equal to sine x. Sine x. I want you to find dy dx. When we differentiate sine x, you get something. So I don't want you to tell me, I just want you to write it out. So if you don't know, just look for the derivative of trig functions. So I want you to find the derivative of cos x, the derivative of tan x, the derivative of sec x or secant x, the derivative of, what's the next one? Let me see if you know them. We have two more.
So cosecant?
Yeah, cosecant. We usually use CSC for that. And we have cot or cotangent. So I want you to quickly use your internet access, and of course you will find what the derivatives are. Just find the derivatives and write them down because we'll be using them in a few. Sometimes when we're doing differentiation, sometimes you have to apply the chain rule as well with trigonometric functions. So let's look at this function. I think I have something. I want you to look at number 32. So just copy that one down. Sine 5x. Good. So if you have to differentiate this, let me hear what you think we can do here. Does it look like a function of a function? Happening here, we are accustomed to seeing just sine something. Therefore, what is the sine? It's basically the sine of 5x we're taking. And as we can see, 5x is a function by itself as well. Therefore, we can let u equal 5x. Is this clear with everyone?
Yes, sir.
Anyone else? Anyone else is there with us? We're going to let u equal 5x. So therefore, what will y be equal to? I want someone else to say. If u is equal to 5x, then when we rewrite y as a function, what will y be equal to?
Sine u, sir.
Excellent, excellent, sine u, excellent. Good. So remember the formula, it's du, it will be dy du times du dx. Right? So let's find the derivative of 5x. So that would be du dx. What will we get when we find derivative there for 5x?
5.
5, excellent. Now we need to find the derivative of y. So dy du, because the variables are y and u in this equation. When we differentiate sine, what do we get?
Cos.
Good. So that would be cos u. Right? Is that clear with everyone?
Yes, sir.
Great. So now all we need to do is our substitution. So dy du, we found that to be cos u. And du dx, we found that to be 5. So I will bring this constant in front, so it will be 5 times cos. And what is the value of u? What was the original value for u?
5x, sir.
5x, great. So the derivative of the function is this. Now, this is why I showed you from the inception that we need the formula. Of course, now that you see how the formula is used, we can do the shortcut. So dy dx derivative, we differentiate the function as a whole. When we differentiate sine, what do we get?
Cosine, sir.
So it will be cos 5x. But we still need to differentiate the inner function. And when we differentiate 5x, what do we get?
5, sir.
5, and we multiply by 5. So that's basically your answer. Is this clear with everyone?
Yes, sir.
Alright, so I'm going to close off this part here where we're doing the trigonometry. Well, differentiation actually uses the chain rule, the concept of the chain rule. So a parameter or parametric equations, basically what they do, they use two separate equations to represent a particular curve. So for example, you might see x is equal to 2t and y is equal to t squared. So this is an example of a parametric curve where the x value can be collected separately and the y value can be found separately as well. Right, so whenever you see x and y separate and there is a common variable, that's basically what a parametric equation looks like. So if we are asked to find the dy dx, basically what we need to do is find the derivative of x and the derivative of y separately. So I want you to quickly, what will we get for dx dt? This should be fast. What's dx dt?
2.
Excellent. dx dt is equal to 2. Now, what is dy dt?
2t.
Excellent. dy dt is 2t. Now, I want you to think about how I can use these two, the x dt and the y dt, to get dy dx. So I'm going to ask you, should I write dy dt times dx dt? Tell me if this is correct. And if it's not correct, tell me why. If it's correct, tell me why. Because that's what we have now. I have dx dt, I found that, and I have dy dt. Tell me if this part here is correct. If you think that is correct. Cancel out dy dt times dx dt. Will I get dy dx? Look at it.
No,
If I
sir.
perform this, great. So I wouldn't get dy dx. So I want you to tell me how I can make some arrangement on this side so that if I cancel out, I get dy dx. What should I do?
Sir, it should be dt over dx.
Yes, sir.
Alright. Good. So it would be dy dt divided by dx dt. Now I'll show you why I put divided by. When we divide with a fraction, what do we do?
Change the multiplication.
Find
Change the
reciprocal.
division sign to multiplication. Sign and upturn.
Wonderful. Wonderful. Right? Good. So basically what you will get now, it will be dy dt times, and we upturn dt dx. So when we're dealing with parametric equations, this is what we have to do. So it's a bit different from the chain rule. Instead of multiplying, we're actually dividing. So if I take this first one here, what we'll end up with for dy dx is dy, and you can take this down please, dy dt over dx dt. So please copy that. So we are dividing in this case. Dy dt by dx dt. That's how we could cancel out to get what we du times du dx if it was a chain rule. But instead of multiplying for parametric, we have to do a division. So that's the only difference.
Okay, thanks, sir.
Very well. Okay. So this is the formula actually. Dy dx is equal to dy dt over dx dt. Now, so for the original problem that we have here, all I need to do is substitute my dy dt. What's our dy dt here?
2t, sir.
2t. And what's our dx dt?
2, sir.
2. Therefore, our answer would be just t in this case. That would be our derivative. Okay. Now, I know it's all jumbled up because I wanted to derive the formula. So what I want you to really focus in on is, let me just, this part here. Everything else outside there was to get the formula. All of this. Good. So I want you to try this one. X is equal to cos t and y is equal to sine t. Let's see if we can find dy dx, if we can find the derivative. Is dy dt. So it means we have to differentiate this, and then we put that over dx dt. Good. So let's talk quickly. What's the derivative of this first function? When we differentiate cos, what will we get?
Negative sign, sir.
Negative sign. So dx dt. So let me write that down somewhere so that we don't lose it. So dx dt so when I differentiate this, it will be negative sine t. Right? So my denominator is negative sine t. That's what dx dt is equal to. Good. When we differentiate this now, dy dt, what will we get?
Cos t, sir.
Dy dt is equal to cos t. So that's my numerator. Dy dt is cos t.
How do you know?
Great. Now, can anyone tell me what cos over sine is equal to? We know sine over cos is tangent. What cos over sine is equal to?
Sir, not sure. Cotangent?
Yes, that's what it's equal to. So when you have cos, but let me just say that this is the answer here, right? If you make it to here, excellent. But you have to remember some of the trigonometric rules is that if you have cos over sine, that's the same as cotangent. Right? So it's cot. And because we're dividing by a negative, it will be a negative cot t. I have to write this t in a different way. Because cot has its own t. So it will be cot t, a negative cot t. That's our answer. That's the derivative of the parametric equation. Any question concerning this?